11. We're talking about logarithms. So we just finished testing over Unit 10 on exponentials last week. Logs and exponentials go hand in hand, just like we did quadratics and square root functions back to back because they were inverses. And then we did a unit with cube and cube root functions. Okay, now we just finished exponentials and we'll be talking about logarithms. Okay, so a logarithm, bless you, is the power or exponent to which a value must be raised to equal some other value. Okay, so logarithms provide another way to look or to work with exponents. Okay, so we're going to be able to rewrite logs and exponents in log form and exponential form. You can go back and forth between the two forms. Okay, so this form on the right should look familiar. This is exponential, x is in the exponent. So you've got some base value b raised to a power equal to something. Okay, now we already talked about in exponentials that base cannot be 1 and it's got to be greater than 0. So it's got to be positive and not 1. Okay, now the log, the x, or I should say the exponent, which in this case is just x, is a logarithm. Okay, a logarithm is the power to which the value must be raised to equal some other value. Now, logs, we call it log for short instead of saying logarithm every time. The log has a base value as well. Okay, so we call that the b. Okay, so log base b of something equals x. These, actually down here, these arrows show it for you. I'm going to highlight and color code. You can convert back and forth between log form and exponential form, or not really convert, but rewrite. So whatever the base of the log is, that is your base of your exponential. Okay, that's why they have the same letter there. B is the base, whether it's the log or the exponential form. Okay, what you are taking the log of, okay, that's called the argument, is what the exponential is set equal to. And then what the log is equivalent to, that is the exponent. Because we said a logarithm is an exponent, right? So we have to be able to convert back and forth between log form and exponential form. So here in example, this first example, we're going to rewrite the log in exponential form. Okay, so I'm going to go through and on all of these real quickly and highlight the different parts of the log. Okay, so what will become the exponent is what the log is set equal to. Okay, what will be the base? Oops, nope. Got too much there. Is that number there, the base of the log. The base of the log is written as a subscript, like in the corner down on the G. Ugh. My highlighter is being very finicky and not highlighting small amounts. Come on. There we go. Nope, too much. Jeez Louise. There we go. All right. So when I come to rewrite those in exponential form, the base of the log is the base of the exponential. So in A, this is a base 2. And then the exponent is the what's in blue here, what the log was set equal to. And that will equal the argument, whatever we were taking the log of, in this case 8. the argument here, base, and the exponent. Y'all feel okay about how I converted that? So let's try it for the next one. Base 9 to the power of 2 equals 81. And these make sense, don't they? Aren't these true? Isn't 2 cubed equal to 8? Isn't 9 squared equal to 81? Yes? Okay. And so this one would be a base 16 and 1/2 power equals 4. Who remembers the power rules that we went over? What is a 1/2 power the same as? One half isn't the same as 2, but when you have a fraction as your power, what does the denominator tell you? That is how could an exponent that's a fraction, fractional exponents can be rewritten as nobody remembers? Radicals, right? A fractional exponent can be rewritten as a radical, and the denominator of the fraction tells you the index of the radical. A radical is a root. So since this is a 2, this is a square root. 1/2 power is the same as a square root. So this could be rewritten as the square root of 16 equals 4, which is true. Now, things that we review and learn and use in previous units aren't just dropping off. You can't just forget everything. It's going to keep moving with us. Okay, so you have to know that a 1/2 power means a square root. Okay, so let me finish my highlighting here. So that was my power. This is my power. Argument. And the base. So far, so good? Just converting from log form to exponential form. You understand what goes where? You can always reference this. Okay. Now, back when we did exponentials, I did talk about different bases of exponentials. When we were doing the parent functions, we talked about how the ones we used most frequently were a base 2, a base 10, and a base e for exponential expressions. And I said that the base 10 was your common base and the base e was your natural base. The same thing goes for logs. Okay, so if you have a log that has a base 10, that's what we call a common log. Okay, so a common log and I guess this is supposed to be plural. Common logs are base 10 logarithms, even though the base is not apparent when written. Okay, and that means you won't necessarily see the base written. If you just see this format, log of something, in this case x, and there is no base means it's a base 10. It's just like when you have this radical, it doesn't have the index written. It's understood that it's a square root if there was no index written. Or if I have something without a power, it's understood that that power is 1. You don't have to write the power of 1, it's understood. You don't have to write the base 10, it's understood. That makes sense? If you want to make a little note of that. So if there's no base written, it's a 10. That's your common log. Now, your natural base, E, okay, is what we call a natural log. So natural logs are base E logarithms, and they are expressed as ln rather than log base E. Okay, so they have a special abbreviation. We use ln rather than log base E. Okay. When we write that, so it looks like this, same thing. You're not going to write the base. It's going to be understood that it's a base E because it's written as ln. Okay. Let's see. E. Okay, when we say base E, that E is approximately equals. This is a typo here. It's not supposed to be equations. It's supposed to be equals. So E approximately equals 2.71828, okay, and is the value that the expression 1 plus 1 over n to the n approaches as the value of n approaches infinity. So they're saying as n approaches infinity, so as it gets greater and greater and greater, okay, your curve approaches this 2.7128, this E value. Okay, that's why it's our natural base. When we write natural log, okay, when I write the word log, mine doesn't look like this typeface with like the little line at the bottom and the top. Mine's just a line, an L. Okay, so sometimes that looks like a 1. So you'll notice when I write logs or natural logs, a lot of times I'll use cursive, or not, like a hybrid of cursive and print, and write them. You don't have to write it right now, but oftentimes you'll see mine look like this, log or ln, because I'll use the cursive or the loopy L just so it's obvious that it's an L and not a 1. Not saying that you have to do that, but I'm just letting you know as I write our notes and do this, you'll see me writing it that way. And that's my reason. That's why I use the cursive L, just so it doesn't look like a 1 and get anybody confused. All right, so we're going to do the same thing here as we did in the previous example, except now there are no bases written on these. So you have to understand that if there is no base written, it's either a base 10 or a base E, and it depends on if it's log or natural log. Okay, so I'm going to rewrite this first one. It's a base 10. Okay, if you see log with no base, that's an understood 10. So 10 is my base, 2 is my exponent, and 100 is my argument. Okay, so let me get our highlighting done again. So the base, there is no base. So it's a base 10. There is no base here either. It won't let me highlight empty space apparently, so I guess I won't be able to do that. And then my exponent, my argument. Okay, so I'm going to do the same thing here in B. There is no base written down here, but it's a natural log, so I know that that base is an E. And then my power is 3. And that must equal what I was taking the log of, or the natural log of, which is E cubed. And that makes sense, right? E cubed equals E cubed. So I'll go ahead and highlight. This was my argument. It's my exponent. And that was my base. Highlight, please. Thank you. All right, let's try it with C. Natural log again, no base written because it's a natural log. It's understood base E. The power is 6. That must equal this decimal, 403.429. And you could check that in your calculator. Remember, you can type E in your calculator just like you can type pi. So you could verify that that's correct. Okay, in D, there is no base. It is a fraction as the argument. And some people are like, looks like that 10 is the base. Well, yes, this actually is a base 10, but not because of this denominator 10. Okay, this is log of 1/10. You can put parentheses around what you're taking the log of if that helps clarify. Okay, but there's no base written here. So the base is the understood 10. The power is the -1. And then it equals the argument of 1/10, which is true. Remember, when you have the negative exponent, you can move the term in the fraction. So in this case, to the denominator, then it becomes the positive power. So I'm going to color code this for us again. So my base those were the common and natural base. And then my argument and my exponent. All right. Still feel okay about that? Converting from log form to exponential form? If no base is written, it's either a base 10 common log or a base E natural log. All right, so let's do that in reverse. So now they're giving us the exponential equation and we want to write it in a log form. Okay, so the same rules apply. The same values are going to be used. So now this is my base of my exponential. So that becomes the base of my log. I'm going to go ahead while I've got my highlighter colors and highlight on all of these. So I'm going to highlight the base. So those are the bases of the exponentials. These are the exponents. And this is the argument. So when I go to write this in log form, A is going to be log base 25 of 5. I like to use parentheses when I'm writing my logs just to keep it clear on what's inside the log function and what's not. Okay, so log base 25 of 5 equals 1/2. For B, it's a log base 10. Do I have to write the base 10? If it's a base 10, it's understood. I do not need to write the 10 down here. So log of 1/1000 equals -3. Here's a base 2. So log base 2 of 16 equals 4. Now this is a base E. Base E means it's a natural log and I don't have to write a base. I just write ln. It's a natural log because that base E of 7.389 is 2. Go do my highlighting here. So my argument became what I'm taking the log of. My exponent became what the log is equal to. And my base of the exponential was the base of the log. Questions at this point? Rewriting from exponential to log or log to exponential? Okay, great. All right, on this next part, here is the process for evaluating logs without a calculator. So if we want to come up with an actual number answer here, we're going to rewrite the expression with an equals x. Because right now it's not an equation, it's just an expression. So we're going to make it an equation by saying equals x, because we're trying to figure out this equals what, right? And then we're going to solve for x. So then to solve that, we are going to rewrite the log in exponential form, just like we just practiced. And then we're going to determine what exponent makes the equation true. So let's start with this first example. We're going to write equals x. So that's step 1. Now I am going to rewrite from log form to exponential form. So it's a base 5 to the power of x equals 125. So now the question is, x is what? 5 to what power is 125? Now we just got through testing on exponentials, and we said when you're solving an exponential, you can get a matching base on each side. If you can get a matching base on each side, then the exponents must be equal, right? So the question is, can 125 be rewritten as 5 to some power? Say again? No. 5 squared is 25, but 5 to the 25th power would not give me 125. If you're unsure, you can use, I know this says without a calculator, because we want to be able to do this. You should be able to do this. Make yourself a list if you need to. I was just going to show you how to make a table in the calculator, but you can also make that table by, whoa. Sorry. You can also make a table by hand and just ask yourself, okay, if x, whatever x is. Excuse me. Writing my table backward. All right, so if x is 1, 5 to the first power is 5, right? What's 5 squared? 5 cubed. There it is. That's the 125. It's when x is 3. So if you need to rewrite this and say, okay, 5 to the x equals 5 cubed. I rewrote 125 as 5 cubed. The fact that those bases match, this is the 1-to-1 property, says that x is 3. Some of you can just skip that step right there and go straight from x to the 5th equals 125 and just say that means x is 3. Don't feel okay about that? Let's try it with b. All right, so my base is 6. We don't know what this equals. That's what we're trying to figure out. So my power is x, and it equals 1/36. So again, some of you can do this in your head and figure out, well, the fact that this is in the denominator tells me that this x is going to be negative. This is a negative exponent rule. And then 6 to what power is 36? squared. 6 times 6 is 36. So 6 squared. Now 6 squared would be 36. This is 1 over 36. That's why that has to be a negative. So that x must be negative 2. If you need to write the step in between where we're getting them to match, I can bring that 36 up by making it a negative power. So if you get the bases matching, then the exponents must be equal, right? That's that one-to-one property from last unit. All right, C, what is the base? Base 10. No base written, it's an understood base 10. And we're trying to figure out what does this equal? So x is my exponent. 10 to what power is 10,000? If you're not sure, do the same thing we did over there for the 5 base and make yourself a little table. 10 to the first power is 10. 10 squared is 100. 10 cubed is 1,000. And 10 to the fourth would be 10,000, right? So that x is 4. When you're looking at a base 10 and it equals just 1 with a bunch of zeros behind it, it's the number of zeros that tells you the power. So there were 4 zeros, so that was 10 to the fourth power. All right, let's look at D. What is the base in D? So this is going to be written as 8 to the power of x equals 64. 8 to what power would give you 64? 8 squared, so x is a 2. You need me to do some highlighting here? Let me go ahead and do that. Bless you. There we go. Bless you. So far, so good? All right. Now, inverse properties of logs. Okay, I already told you at the beginning of the notes, the reason we are talking about logarithms now that we finished exponentials is because they are inverses. They go hand in hand together. Okay, the inverse of an exponential function is a logarithmic function, and the inverse of a logarithmic function is an exponential. Exponential and logarithmic functions, they negate each other or undo each other because they are inverses. Okay, the inverse properties of logarithms can be used to simplify exponential and logarithmic expressions and are useful for solving exponential and logarithmic equations. So what this is saying, zoom in on this. If you have a log with a matching base to what you are taking the log of, you are simply going to be left with the exponent on that value. Because a log base b of b undoes each other. Okay, the base of the exponential and the base of the log are equivalent. You're going to be left with just that x from the exponent. Same thing in reverse. If you have an exponential expression and there's a log in your exponent, the log is the exponent, but the base of the log matches the base of the exponential, those are going to undo each other, negate each other, and you're going to be left with simply that value of x. Do y'all understand that? So looking at that with some numbers plugged in, look at this first example. So this one matches this format over here. You've got a base value raised to a power where the log is in the power and the base of that log matches the base of the exponential because there's no base on this log. It's an understood base 10, right? And this is a base 10. So those are going to undo each other. And what are we going to simply be left with? If the log base 10 and the 10 here are going to undo or negate each other, what are you going to be left with? 3x over 4. That's it. This one is that same format. You've got a base e, and then in the power, you have a log base e. That's what ln means. It means log base e. Your natural log is a log base e. So what are you going to be left with here? Just the x plus 2. Now, I am going to have you add something here because it's missing. Up here in the exponent, the natural log, I want you to put the x plus 2 in parentheses like that, please. All right, now C is not in the same format of those others. It's not an exponential with a log in the exponent. It's a log. So this one matches the format of this one. Okay, where we have the log and the base of our log matches what we're taking the log of. Because ln tells us it's a base e, and then we're taking the natural log of e. So those are going to negate each other, and what are we simply going to be left with? The 5x. The base e is understood down here, so those e, the natural log of e is going to negate. Okay, let's see. This next one is this format. You've got a 2 to the power of log base 2. So 2 to the power of log base 2, what am I going to be left with here? Two to the power of log base 2 is going to negate. I'm just going to be left with the 7x plus 8. This is that same format. And then the rest of these are the log format. But the same rule applies for all of these. This is a log base 0.1 of 0.1 that's going to negate, and I'm going to be simply left with the 12x. Here, log 1/2 to the power of log base half. It doesn't matter that this one's written as a fraction and this one's written as a decimal. 1/2 is 1/2. That's still the same, which is going to make me be left with simply that x. Y'all have a good one. No new assignment tonight. Simply finish any late or missing work from Unit 9, the review or either of the last 2 Delta Maths. I'm going to go ahead and finish this up for the video. So again, log base 2 of 2, going to negate, and I'm going to be simply left with the negative x over 7. Here, the base is an understood 10, so log base 10 of 10 is going to negate and just leave me with x minus 9. I'm going to move this up here. So that is the property of inverse, the log inverse property that lets those simplify in that format. Give the exit ticket a shot. We'll start the day tomorrow going over that, but see if you can evaluate that log. That is similar to the examples we were doing right up here in example 2. Getting an evaluating, set it equal to x, rewrite it in exponential, and figure out what that x would, what that x would be. All right.